Hello class, this is the final video on the sum and product of roots. In this video we'll be looking at how we can continuously apply what we've seen to higher degrees more than 3, or a power of 3. So if we had 4 roots, alpha, beta, gamma, delta, and we were to expand it and collect all the like terms, we would get the following: x cubed minus alpha plus beta plus gamma plus delta, x cubed, plus this one's going to be, take a look, alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, gamma delta. And if you're wondering how we find those, we pair them up. This one plus this one plus this one plus this plus this plus this. So we're finding all the different combinations of 2. Then we do the same thing for the different combinations of 3. So 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. There they are. And the last one's easy to remember. Alpha, it's just the multiplication of all 4. And those are equivalent to, this is equivalent to B on A, this is equivalent to C on A, and so on. Now you don't have to remember these. We're just kind of showing you that we could continuously apply this pattern to higher and higher degrees. Here it is for degree 5. It is outrageous, but I think you get the idea that it's just going to be all of them individually, all of them in pairs, all of them in triples, all of them in quadruples, and all of them multiplied together. And those are equivalent to, as you'd expect, the equivalent coefficients. And the 6th degree, I'm not going to do that there. And I think you get the idea from here. So let's do an extending question here. You can pause it and give this a go yourself. So let's take a look. This is a degree 4. So let's grab the identities for a degree 4 and let's use them here. The first one's very simple. It's just alpha, beta, gamma, delta. It's just the multiplication of all of them. It's E on A. So alpha, beta, gamma, delta is equal to -3 on 1. That's just -3. All the triples, alpha, beta, gamma, alpha, beta, I think you get the idea. The triples are these ones here. Well, that's just going to be -D on A. Well, notice how there's a 0x squared there. So there's a bit of a little hack there. That's going to be plus 0x squared. So that's going to be A, B, C, D, and then E. So for this one, it's going to be -D on A. So -7 on 1, which is just -7. As for this last one, we've probably seen a similar question using the cubic. For this, we need an expression where we have the same denominator for all of them. So alpha, beta, gamma, delta. And now for alpha to become this, it's missing the factors of beta, gamma, delta. So 1 times beta, gamma, delta will give us beta, gamma, delta. Plus, likewise for this, beta is missing the factors of alpha and gamma, delta. So this is going to be alpha, gamma, delta. And I think you're going to see where this is heading towards. The next one here, this needs alpha, beta, and delta. Alpha, beta, delta. And the last one needs alpha, beta, gamma. these are just the sums of all the triples once again. Here they are. So the top is the sum of the triples, which we already know. And the denominator is the multiplication of all four. So substitute those. The numerator becomes -7. The denominator becomes -3. And this is simply just, let's go vertically, 7 on 3. And this is just a short example for for the 4th degree. You can imagine this being applied to the 5th, 6th, 7th, or even 8th, whatever degree. So I hope that gave you an insight into the sum and product of roots. Hope to see you in the next video. Best of luck.